Okay, example 7. So let's let theta in radians be an acute angle of a right triangle. So let's sketch a picture here. So let's let theta be the angle down there. At a certain instant, x equals 4 and is increasing at 2. So let's call this x. So we're not going to label x equals 4 because that's just the instant that we're talking about. But we do know that dx dt is 2 units per second. And we're also mentioning y here. So while y equals 3, it's decreasing at 1/2 a unit per second. So dy dt would have to be negative 1/2 units per second. Again, keyword decreasing. How fast is theta changing at that instant? So we're trying to find d theta dt. So if we just focus in, we're going to draw a separate picture here, and we're going to focus in on the actual instant that we're interested in. X is 4 and the y value is 2. Now we're not going to bother doing Pythagorean theorem. We don't care about the hypotenuse. That side is not mentioned in the problem. We are going to eventually need to find theta. Okay, so more on that in a little bit. So first, let's go back and look at these quantities here. We have an x, we have a y, and we have a theta. So it's not like the last question or question before that where we knew a fixed distance. Alright, so like we knew that the ladder was 13. That was fixed. Here we don't have any fixed quantities. All we have to work with is the two sides of this right triangle and that angle. So once again, we need an equation to relate these quantities. So we're going to need trig again. But this time it's not going to be cosine. This time, if this is our angle, this is an adjacent side and this is an opposite side. So that's tangent. So we know that the tangent of theta is equal to y over x. So we need to find our derivative of each side. So the derivative of tangent is secant squared of theta. Our variable here is theta, so we tack on a d theta dt equals, now we need our quotient rule. Okay, so low d high would just be 1, and I just took the derivative of a y term, so I need a dy dt. So there's my low d high minus high d low. Well, the derivative of x is just 1, and I just took the derivative of an x term, so I tack on a dx dt all over low squared, so that would just be x squared. So as far as plugging in goes, remember we're trying to find d theta dt. Alright, so that's what we're trying to find. Alright, we know what x is, right? X is 4, we know that y is 2. We know the rates for dx dt and dy dt. The only thing we don't know is this theta. So we need to find theta at the moment when x is 4 and y is 2. So we know that the tangent of theta in this case would be 2 over 4, right? Opposite over adjacent. So to get our theta, we have to do inverse tan of 2 over 4 in the calculator. So go ahead and do that. Oops, sorry, just occurred to me that y is 3, not 2. So we're going to make this a 3 over 4. Alright, I'm sure you've already caught that. So when we do inverse tan of 3 over 4, we get 0.6435. Oop, my phone's ringing. Excuse me for a moment. Alright, so anyway, here is our angle at the moment when x is 4 and y is 3. So let's plug in all this information. Alright, so let's take a look at what I've done here. So we plugged in everything. Alright, we have the secant squared of our angle, d theta dt. I put 4 in for x, negative 1/2 in for dy dt, 3 went in for y, 2 went in for dx dt, and then the x squared is 4 squared. Now, we're looking to solve or isolate d theta dt. So dividing over secant squared, alright, that's what we would have to do to get it alone. remember that secant squared is the same as 1 over cosine squared. So since secant squared is the same as 1 over cosine squared, dividing all of this by 1 over cosine squared is the same as just multiplying that quantity by cosine squared. Now, cosine squared means you really have this whole quantity squared, okay? So we enter all that into the calculator. We get negative 0.320, and we're talking about d theta dt, so that's referring to the rate at which the angle is changing. So theta is changing in radians per second. All right, so this would be our final answer. Oh, and then the piece about is it increasing or decreasing? Of course, it's decreasing because of the negative. Okay, here's our last example. We were talking about a cone, and we have this cone-shaped paper cup. It's being filled with water. So let's try to sketch this here. So we have something like this. There's our cone. It's being filled with water at a rate of 3 cubic centimeters. So right away you see the cubic, think, okay, that's the volume. Okay, it's being filled at a rate. So dV dt would be 3 cubic centimeters per second. Okay, the height of the cup is 10. So the height is 10 and the radius of the base is 5. Now those are fixed quantities. They're talking about the dimensions of this cup. So we're going to come over here and we're going to label this. The radius here is 5 and this height h is 10. Again, we're going to label that on our picture because those are fixed quantities. Now, we're looking to find how fast is the water level rising. So think about which variable that's referring to. The water level rising. Well, rising is moving upward. So we are looking to find dH dt, not dr dt, dH dt, right? The height corresponds to the water level rising. All right, and we're looking to find this when the level is 4. So that means when h is equal to 4. All right, so we need an equation here for the cone, and we're talking about volume, right? So we mentioned earlier that the volume of a cone is 1/3 pi r squared h. Now, this is more complicated than all of the other examples that we've seen. Okay, the first 7 examples were easier in the sense that we had just one variable in our equation. Well, now we have both an r and an h. So very similar to when we did some optimization problems, we want to make sure that we are rewriting this in terms of just one variable. The next question becomes, well, do I want to rewrite this in terms of r or h? Well, you have to look at what's given. We are given that h is 4, and we're trying to find dH dt. So that means we need to rewrite in terms of h. Okay? So, how do we do that? Well, the only way to do that is to be given some fixed quantities like we were. We know that when the height is, well, we know that the height is 10 and the radius is 5. Okay? So think about what that relationship is. Okay? Now, to help you see the relationship, you can make a proportion. H over R would be 10 over 5. Cross multiply, 10R equals 5H. Our R would be 1/2 of H after we divide over that 10. And you don't have to make a proportion like that. It's certainly possible to just look at it and determine exactly what that relationship is. In this case, it's pretty easy to do. All right, so we're solving for R here because we are going to replace R with something in terms of H. So when we say rewrite in terms of H, that means we only want H's in the problem. So let's substitute in. We're going to have 1/3 pi. Now I'm removing the R and I'm going to replace it with what it's equal to, which is 1/2 H. And then I'm going to square it, and then we still have that times H. So now we can see that it's been rewritten in terms of H. So we know we're going to have to find a derivative, but the most common mistake I see year after year is people are too quick to take their derivative. There is a considerable amount of simplifying here that you can do to make your life a lot easier. So clean this up, simplify it as much as possible. So we have this 1/2 h quantity squared, which will produce a 1/4 h squared. So this 1/3 times that 1/4 will give us 1/12 pi, and then you're going to have an h cubed. So again, I can't stress enough, simplify it as much as you can. Okay, don't waste your time trying to do the product rule or something crazy like that. Simplify it, and then from there we are ready for our derivative. Okay? Okay, so our derivative here, let me go off to the side. We'd have dv dt. Now we're going to do our power rule, so multiply that 3 down to that 1/12. You get 3/12, which is 1/4, and then pi h squared. Please excuse my kids in the background. So we have a dh dt because we just took a derivative of an h term. So from there we can plug in. So we're trying to find this quantity dh dt, and so the dv dt, we were told that that is 3. We have 1/4 pi. Now the h value of interest is 4, so we have 4 squared, and we're trying to find dh dt. So let's clean this up. We'd have 3 equals, well, this would be 16 divided by 4, so that would be 4 pi dh dt. And then our dh dt would be 3 divided by 4 pi. And remember that if you're doing this in the calculator, make sure you put parentheses around that entire bottom, or else you're not going to get the correct answer. So here's our exact answer, and that would equal 0.239. So this is a rate at which the height is changing, or the water level is rising. So centimeters per second would be our final answer there. Okay? So this is really as complicated as it gets, and that's because you have more than one variable in your initial equation. Okay?